So we want to talk about the properties and changes of matter today. We already touched on what the chemical and physical properties of a substance are. Now we're going to go over that in a little bit more detail. So remember, physical properties don't involve changing the composition of the substance. We have a pot of water boiling here. Uh, the fact that it's boiling, it turns to steam. The steam is still made up of hydrogen, two hydrogen molecules or two hydrogen atoms for one oxygen atom to make a water molecule. So there is no change in the identity of the substance. So some qualitative properties. We have these are description properties. So we have that the water is clear. Um, what other qualitative properties can you think of? We know that it's a liquid. We know that it's odorless. Anything that's describing it is a qualitative property unless we add numbers to it, then it becomes quantitative. So some numerical properties are actually the boiling point of water is 100 degrees Celsius, or we have 4 cups of water here. That's telling me how much volume of water we have. Those are quantitative properties. Or if you told me how many atoms of water there were. Anything involving number is a quantitative property. States of matter are also a physical property um, because, like I said, you're not changing the identity of the substance. The three main states of matter are gas, liquid, and solid, depending on the temperature and the pressure at which they're located. The fourth state of matter is less common, and we'll talk about it later. It's called plasma, and that's for superheated substances. So just real quickly, why do you think freezing and boiling points are physical properties and not chemical properties? Hopefully you realize because as we said, the identity of the substance is not being changed. When a substance can change into a gas easily at room temperature, these are substances that we normally can smell because the gas molecules of that substance are entering our nose. Those are called volatile. So gasoline, alcohol, those types of things, perfume, those are volatile because they have an odor associated with them because they change from to a gas at room temperature easily. Another physical property that we'll go into detail about is density. Density is how much matter is contained in 1 unit of volume. So obviously this styrofoam ball is roughly the same size as the bowling ball, but the styrofoam ball will be much lighter and easier to pick up than the bowling ball because there's more mass packed into every unit of volume of this bowling ball versus the way the styrofoam ball is composed, the way it's structured, there's not as much matter for every unit of volume. On the other hand, so everything we've mentioned so far is a physical property. Now, on the other hand, chemical properties can only be seen when the composition of the substance changes. So back here we have this rusty tracker. Uh, the iron has actually reacted with the oxygen to form oxygen or iron oxide, which you otherwise know as rust. Um, Anytime we have a chemical property, that's going to require a chemical change. And one reason that hydrogen peroxide is stored in brown bottles is to help shield it from light because a chemical property of hydrogen peroxide is that it um, will break down if it's exposed to light for too long. So that's why it's stored into brown bottles, just to keep it away from the light. Another example of a chemical reaction. Let's actually look at a couple of those. Uh, Here we have the reaction of aluminum with bromine. And another example of the iron burning in oxygen, another chemical reaction. You know, the two things are usually observed. Finally, one last example I'm going to show you is this one where we have the electrolysis of water. As you can see, this battery is connected to um, the water under two different test tubes. And what's actually happening is that the positive end of the battery is causing hydrogen uh, to come to it, and the negative end is attracting the oxygen molecules. It's actually pulling the liquid water, which is composed of two hydrogen atoms and an oxygen atom. It's actually pulling that apart, breaking it into oxygen and hydrogen. So this is actually an example of the law of conservation of mass, which basically states that matter cannot be created or destroyed. Um, but before I get into that, I just want to go over some other examples of chemical reactions. We saw some things burning and exploding. Anytime you hear the words like decompose, explode, rust, oxidize, corrode, tarnish, ferment, burn, rot, those things are all going to refer to chemical reactions. Things like dissolve, melt, boil, those are all going to be related to physical properties or changes. So back to this law of conservation of mass, basically saying that matter cannot be created or destroyed. So no matter what I do to that water, I can't destroy the atoms that make it up. I just move them to another place. Um, they become oxygen and hydrogen gas. So that works throughout any matter in the universe. No matter is created spontaneously or destroyed spontaneously. It's only rearranged. But all chemical changes do involve some sort of energy change. Energy is the ability to do work. Uh, Heat is a type of energy. Well, heat is not a type of energy, but heat is often given off uh, when chemical reactions occur, or it can also be absorbed. So one example is candles. When candles are burning, when the wick is burning, it's giving off heat. We call those reactions exothermic. You can think of exo as exit, meaning outer. It's giving off heat, so it's exothermic. On the other hand, for instance, when you think of an ice packs are cold when that chemical reaction happens when you break them. So this is one of those instant ice packs that is room temperature until you break it and then it becomes cold. Well, when it becomes cold, it's not giving off cool air. It's actually what it's actually doing is taking heat from your body. So the heat goes from your body into this ice pack. It's bringing in the heat, meaning it's endothermic. So exothermic gives off heat, endothermic brings in heat. So do you think photosynthesis is an endothermic or an exothermic process? Remember, photosynthesis is the process plants go through to make their food. They take in the CO2 and sunlight and water to make sugar for food. They also produce oxygen. Well, as you can see, light is the energy which is actually going into the reaction. And since it's absorbing the heat, we're actually going to consider it an endothermic reaction. It's not giving off heat. So plants might decrease slightly in temperature due to photosynthesis because they're actually absorbing heat in that reaction. So let's just review. I want you to think of whether these following things are chemical or physical properties. Aluminum bends easily. That's a physical property because when you bend aluminum foil, the foil is still aluminum. It hasn't changed its identity. Copper sulfate dissolves in water. That's actually still physical because if I were to evaporate the water, I can separate these things by physical means. If I were to evaporate the water, the copper sulfate would be left behind in its original form, so no chemical change has occurred. Magnesium burns in air. Remember, we said that anytime you see the word burns, that indicates a chemical change. So this is a chemical property. How about gold jewelry is unaffected by perspiration? Again, that's a chemical change or a chemical property because we're talking about how there's actually a lack of chemical reaction between your perspiration and the gold jewelry. So again, that's a chemical property. Baking soda is a white powder. That's a physical property because we're just simply describing it. There's no change in the baking soda. Finally, ask yourself this question. A friend says a newspaper is completely gone after it has burned in a fire. Is he correct? And if you're having trouble thinking about this, think of it in terms of the law of conservation of mass. Finally, is the burning of wood an endothermic or exothermic reaction? Just to remind you, an endothermic reaction involves absorbing heat, and an exothermic reaction involves giving off heat.